First Canvas Software Conference is about to begin. Wasn't recorded live. And hello everyone. So welcome to the first Canvas Software Conference. And it's going to be virtual. Initially, we decided to host it in Hawaii and in Cairo, Egypt. But because of the current situation, we're gonna make it virtual. But probably in future, we're gonna host the future conferences in Hawaii or any place in the US or Europe or anywhere in the world. But first, before we begin getting into the keynote and doing all kinds of presentations, first let us bring into focus of what we're going to talk about today. We have this beautiful personal touch computer on the side, and we have the beautiful solar powered wireless power dock pyramidal shape. So we have this Cairo and Hawaii theme, and so delving into the sequences, there'll be 4 sequences that we're going to cover today. And the first sequence is Fireside G-Code, which is how these touch computers, personal touch computers, Lila and 2 Square, which was 4th generation and Wi-Fi, is transitioning to Mars 5th generation with Touch OS, completely Touch OS. So that's the focus of the conference, is transitioning of all the advanced design and modeling softwares which helped build the solar wireless power dock using 3D printers, and all these softwares for 3D printers and all these advanced softwares, and how they're transitioning to Mars Touch OS is our focus and first sequence. And the second sequence would be iObjects 2.0, augmented reality and the future of web, and how it'll be very interesting how iObjects 2.0 will cover a lot of various fields, and how we can innovate how we can innovate future of the web with HTML5 and all sorts of things. We'll touch upon AR and iObjects 2.0 and the future of the web and web apps in second sequence. And so the third sequence would be introduction of solar wireless power dock, which we did in social media, and also we're gonna put the spotlight on how it's made, how it was 3D printed using all these advanced softwares, design modeling softwares, and how it was turned to G-code, and how we can transition to Touch OS and how it's made. That's basically the third sequence. And the fourth sequence will be dedicated to touch computers. It's a culmination of all we talked about in all the first 3 sequences, which involved making and designing using 3D printers, and how let me show you a video, and I'll show you a video on the keynote, and I'll add a video and pop it up on the on the video. I'll pop it up now. And yeah, you can see how how 3D printers can make different kinds of shapes and whatever you want in X, Y, and Z direction using just touch computers. The possibilities are endless if we can couple all these advanced softwares, design and modeling softwares, and make it and use 3D printers. It'll be so efficient because of the personal computers and post-personal computers are not that effective, and it's great. I mean, it's good what it's been done, but we are transitioning to touch computers from post-PC and PC era. So we are ushering in a new age of touch computers where amazing things are possible using a hell lot of softwares, these incredible and amazing softwares, and combination of touch computers and 3D printers. So basically that's the synopsis of the first software conference, and we'll go through a step-by-step insights into all of these sequences. So this is basically the essence of the first software conference, and it's so exciting, to start the first software conference with 3D printing as a focus. And it's a start. I mean, 3D printing is a start, but we're gonna move into other advanced softwares later. But we're gonna also focus on the future of web and web clients and the web apps, that HTML5 based apps that are gonna come in Sequence 2 and iObjects 2.0. So this is basically it, and let us start the conference. And we'll have developers, relationships and supplier relationships, and we're gonna also focus on reports, sales reports, and future of touch computers and sales in the final sequence, which focus on touch computers and transitioning to Mars OS, Touch OS, and March 5th generation cellular network, which is for 2021. And we're gonna end 2020 with the first software conference, and you'll have some more slides and some videos and audios and some design intros, and it'll be a nice ride and fun ride, and you can just sit back and relax and enjoy, and just watch the design, how we can use our touch computers to design all of these stuffs and bring things to life. And thanks a lot. So let us delve right into the conference with sequence 1. But before that, we'll do an introduction on what's computers and what's touch computers, and let's show what's touch computer is, and we'll do an introduction of how humans are tool builders. We'll cover the basics of touch computers and introduction of Solar Wireless product, and then we'll focus on the conference. It's pretty much robotic in the sense that it's a computer chip which runs the printer, and it's kind of acts like a robotic giant. But it's pretty simple, that instructions are fed to the printer and it moves in X, Y, and Z direction. That's it. It's that simple. And so what happens is, when you program in NG code, all it does is the instruction is fed in Rerelease Wireless, and it goes through the machine language and asks the machine to do pretty much simple things in a few minutes. A large design file would take a lot of time, but it's really faster than humans, and it does it so fast, based on the instructions. Really, it's human instructed machine, and what it does is, like, depending on the size of the file and size of the instructions, it just goes in all sorts of directions and layer by layer and does the job. And it's software, hardware, industrial design, and everything combined together, to make such beautiful, pretty objects. You can literally make almost any shapes and sizes you want, limited sizes and shapes. So, and another interesting fact is that you can not just design, but you can actually control the flow, the temperature, the bed temperature, speed. Sometimes really slow speed can give you a really high quality, but sometimes you can increase the speed. For example, for a monotonous concurrent patterns, you can just increase the speed. And for some first layer, you can just decrease the speed and set optimum values for the flow of the filament, which is biodegradable and environment-friendly bioplastic PLA filament or any other filament that you want. And it just extrudes, and all these instructions are provide the motors actually moves these extruder in the directions, and its software programming asks the machine to do to move certain directions. And it's a combination of motors and computer chips and memory and EEPROM and design files and another computer attached that's gonna make the machine work. And another interesting fact is that we are always using standard computers to operate these things, but what if a touch computer which can help all these advanced softwares design better, work better? It's ease of use and intuitive. Touch computers are more intuitive and ease of use than the traditional computers, because obviously all computers are going to be touch someday, but the percentage of or the number of usage case scenarios is drastically reduced because of advent of post PC revolutionized the world. I mean, it changed a lot of industries, and post PC came by a storm, came with a storm and revolutionized a lot of fields. And touch computers is on the verge of making a big splash of a revolution. And we are at the forefront. Canvas has always been at the forefront of touch computers from 2014, and I conceived before that, but we've been more with Canvas 2. We really went for post PC to touch PC transition. Canvas 1 was for digital media, photos and art, but with Canvas 2, which is very popular, we really went into the touch computers age. And Canvas 3 was pretty successful with industries and other fields, and Canvas 2 and 3 were pretty successful with industries and a lot of fields. And Canvas 4, which is LiDAR, and 2 Square, was a pretty project assessment and in the sense, but also designed for enterprise. And it was the start of touch computer revolution. Previous products were the Brink, but it was the start. And with software coming up from baby to advanced transition, and we are in completely transition to multi-touch OS, and all these advanced softwares would find an ease of use and intuitive platform with our OS. And so the basic factors, so with the combination of a touch computer and a 3D printer would enable humans to do a lot of amazing things. I mean, it expands human possibilities, and you give a bunch of instructions via design softwares, and it's automatically transition to to instructions that gonna help create whatever magical objects or designs that you want to create, and in like less amount of time than is humanly possible. And that's why computers are smarter than us. And so it's a pretty interesting. I think we're at the nascent stage of leapfrog evolution and revolution. And and if you say 3D printers, like I said before, it's pretty simple. And not just for 3D printers, but a lot of softwares that are coming up that's gonna be available for Mars Touch OS. But we're gonna start with what we can pragmatically do. So we're starting with 3D printers and Mars Touch OS. So most of the things are computerized. Say phones were computerized, and music players were computerized, and so what, it's a computer. And now 3D printers are computerized, and but these are all interconnected. It's interconnected and integrated. With help of touch computers, the future is going to be more bright, and they're going to be really innovative, because these softwares will solve a lot of problems in a lot of several different fields. And touch computers is what you really need, in terms of ease of use. From wherever you are, you can just pull up your computers and just do whatever design and pick it up where you left off, and do wonderful things with it, than using a bulky or redundant stylus or keyboards and mouses and stuff. So we are heading in the direction, and it's a pretty healthy period of innovation with all of these softwares such as Cura, Mass Mixture, and Blender, and a lot of brilliant softwares. And I think these advanced softwares, needs a multi-touch OS, so that they can, so that's easier for humans, and not just easier, but more flexible, and it'll enable more creative stuff to happen, and productive stuff. So that's basically just basically scratch of what touch computers can do, and 3D printer is just one segment, but there are a lot of other things what Mars Touch OS would be doing as we transition to OS 2. So that's what that's the future of computing and computers, and how it's designed and how it's carried forward. And we put these stuff in the hands of, our goal is to put these in the hands of whoever wants it, to do wonderful things with it. And so we are just enablers of humans, and humans are tool builders, and computers the most wonderful tool that humans have ever invented, one of the most wonderful things, and so powerful. And touch computers is just amplifying what humans have already done. Touch computers going to amplify with the design softwares and other stuff to build tools, to create tools, be it software, physical objects that you're going to print out of a 3D printer, or various other productive stuff that you're going to do on the Mars Touch PC, because it's just a segment, but there are a lot of wonderful things you can do with it. And for example, it's basically it's not a standalone computer. 3D printers are is complementary to actual computers, because they are computers which is run using codes, a bunch of instructions, but basically they act as a complementary to traditional computers. But now it's gonna be I think the marriage of 3D printers and touch computers is gonna be it's gonna be fantastic, and it's bioplastic and environmental friendly, and the way forward. So it's pretty exciting. So That's what I want to talk about, design and computers, touch computers in general. And so, yeah. And to actually feel and touch three-dimensional objects on the touch display, and like say for example a circle, a sphere, a rectangle, a square, and you can just modify this object, the shapes of the objects like pottery, and we can actually touch and manipulate and play with these objects and make them into different shapes and sizes and drag and do all kinds of these gestures. We can do a lot of gestures, which instead of a mouse pointer, we can use fingers that we are born with. That'll be fantastic. And so that's what the transition to touch computer means. And so we are drilling some objects. It's all 3D printer objects. We used all safety precautions. All safety precautions were followed while doing this. So when you design these objects, you design these objects on touch computer, and when you can use how we are using tools to actually do things. It's the same way when you can touch objects on a touch computer. That'll be fantastic. That's why we are emphasizing on the transition to touch computers. Some drilling and screwing, all safety precautions were followed, and so that's pretty much the end of sequence 1 and 3, and we'll have some more keynote on sequence 3, or a few keynotes, and that'll be end of sequence 1 and 3, with some more keynotes to follow. These this is pretty much magical to create things, and I cannot stress more that humans are the most wonderful tool builders, and computers are the most wonderful tools we have ever come up with, and touch computers is the next phase. Touch computers is gonna be the next revolutionary thing, as we have crossed the post-PC era. And so there'll be more a few slides about on sequence 3, and then we can wrap up sequence 1 and 3, and sequence 2 and 4 will be in a different session. Some more photos for you to enjoy. Thank you.